You might have heard that we are entering the era of robotics. And the question is this just another hype cycle? Or are we actually in a pivotal moment? And are lives going to change forever from this point on? If you're suspicious of that, you have the right to be, because our society has been talking about robots arriving for the past 100 years. So as early as the 1920s, we've been talking about how automation, machines are getting better, AI is getting smarter, and we're going to have robots at the workplace and in your home. And that begs the question that, where are all these robots that we've been promised? And how is it that still in 2025, with all the advancements in technology we've had, we don't have a robot like Rosie from the Jetsons that can go around the house, do the dishes, do the laundry, so you can spend some more time with your family. And I should say that I feel partially at least responsible for this, because I've been working in robotics for the past 15 years. I started working on prosthetic control, prosthetic devices. I've made, together with Rethink Robotics crew, a collaborative robot arm that could work side by side with humans. And then at Boston Dynamics, I worked on Spot the quadruped robot and our humanoid, and I was teaching these systems how they could manipulate objects in the world, how they could turn levers, open cabinets, flip a switch, all by feeling how the robot can interact with these objects. And after these 15 years, I think I finally have the answer as to why we don't have these robots just yet. And the answer is that robotics is really hard. And in fact, robotics is a combination of a few different hard things. So for robots to work, first you have to get the software right. That's the intelligence. The software has to tell the robot how to interpret the world, and it also has to tell the robot what sequence of actions to take to actually do something useful. Once you have that, you obviously need the hardware. So you need actuators that can move the joints of the robot, and as a whole, can move the entire body of the robot and have the robot exert forces on the environment and do useful things. You also need sensors to perceive the world. So you need cameras, both color and depth sensors, to be able to see the world around you. And you need touch sensors and force sensors to be able to feel how objects feel, to be able to manipulate them, and also to be able to walk. And then once you have all of this, you have to get manufacturing right. So you have to build this system reliably and robustly, and you have to get to economies of scale in order to bring the cost of the robot down enough so it's actually useful. And when you build a business, you want to make sure that you have the right returns on your investment, and if you ever want to have a hope of working side by side with humans, and especially go to the home, you have to guarantee safety. These are all big challenges, but by far the biggest challenge so far has been the software. And this has been the single most important bottleneck to robotics. So much so that we have a name for this difficulty. And that's called the Moravec's paradox. And what this basically says is that things that seem easy for humans and kind of come as second nature to us are very difficult for robots. And things that might seem hard for humans are actually sometimes easier to code up in machines. Basically, what this means is that we get to build a chess engine that can beat a grandmaster of chess before we can build robots that can take simple steps, or before we can build robots that can grasp objects of different sizes, manipulate them, and stack objects together. These are things that a 1- or 2-year-old human baby learns to do very fast, and robots have been failing at this for a long time. And the internet is filled with a lot of videos of robots failing up until now. But things are just about to change. And to understand that change, I want to walk you through the evolution of robot software and how things have evolved and where we are now. So I'll break this into 3 distinct phases. The first phase is the phase of robots that were doing predefined moves. So these were robots that would go from position A to position B. They didn't really have a perception, so they couldn't really see the environment. They just knew how to execute this task. And because of this, they were inherently not safe, and they could operate in only environments that were precisely manufactured and everything was in the right place. So these robots were tremendously helpful for the automotive industry. But as soon as something moves by a centimeter, these robots fail. And that's why we're entering the second phase of robotics software, which is what I call the planning and perception. So in this phase, engineers like myself would design highly complex algorithms for the robot to be able to do a very specific task. So for example, you would write an algorithm that tells the robot how it would spin itself in the air to be able to do a backflip, and this algorithm would run that specific task. And the robot also had perception, so in this case, our Boston Dynamics robot was able to see the boxes and be able to plant its feet and jump on the right boxes. And usually this would work, and often we had failures. But the biggest and most important thing here was that these algorithms were set for specific tasks. We're now entering the third era of robotics, and that's the era of AI-powered robots. And the beauty here is that these robots are powered by the same kind of AIs that drive your ChatGPT and drive your image generation technology. And these are technologies that actually generalize beyond tasks. So essentially, we have general learning machines now and general learning algorithms. And that's why we're also excited about the state of things. So to kind of summarize this trend, I would say that we started with robots that had an Excel sheet for a brain. So essentially, they were going through the rows and hitting them one by one. And that was the first era. Then we entered the era where we had robots that had a chess engine for a brain, solving complicated equations to solve a specific task. And now we're entering the era where the robots have an LLM, a large language model for a brain, and they can generalize across tasks. So what is so magical about this new wave of AI algorithms? I alluded to it, but the most important thing is that these algorithms generalize across tasks, but also across domains. So the same LLM that is driving your ChatGPT, and you can ask it a question about how to make a recipe, and it gives you a step-by-step instruction on how to do that, is now planted into a robot brain. And someone can ask the robot to clean their kitchen, close the cabinet, and do the dishes, and the robot is able to first understand the language, understand the prompt, plan that as a series of actions that it has to do to achieve the task, and then also understand the environment, and as a function of that, decide on these series of tasks. Another thing we're excited about is the same technology that was used for image generation for the DALL-Es and stable diffusions of the world, if you've generated an image, is now transitioning to robots. These algorithms were able to generate images from a prompt that a human gives it. So you say, please give me a cat, and it starts from a blank slate that kind of looks like noise, and iteratively turns that into a cat. And these same architectures are now being used to have robots do complex, continuous tasks. The analogy here is that instead of these algorithms generating continuous pixels on a grid, these algorithms are now generating continuous joint positions and forces along time. And this is why these robots now work doing complex tasks like folding and laundry, which was never done before by being able to hard-code it. Now, with all of this technology and all the advancements in algorithms, does it mean that robotics is solved? The answer is not quite yet. And the main problem to that is the problem of data. So one main reason why ChatGPT and image generations of the world worked is because the data they needed exactly existed on the internet. ChatGPT has to be able to respond to a question you ask it. And the internet is filled with pairs of questions and answers and sentences coming after each other. So ChatGPT can learn how to produce text. But the same kind of data doesn't exist for robots. To be able to automate a task, a robot has to feel how it feels to do that task. It has to feel what the joint is feeling, what forces it's feeling, and what the cameras are seeing, firsthand in an embodied kind of way. And that data has not existed. And that's why researchers in our field are now focusing on teleoperation, which is driving the robots through a system of joysticks and teleoperation, guiding the robot on how to do a task, and through that, the robot seeing how it feels to do a task and then learn it. With all of this, the question is, are we nearing the end of the Moravec's paradox? Meaning that are robots now able to do the things that seemed simple to humans and were almost impossible for robots? And I think the answer to that is yes. But does this mean that we're going to have robots running around and doing things for us next year? I would say we're not quite there yet. And the analogy here is that robots are where Palm Pilot was a few years ago, if you are old enough to remember that. And robotics needs the revolution that iPhone had to happen for robotics to actually be able to be all around us. So I'd like to close by saying that my main goal is not to build the most powerful, strongest, fastest robots only. And I didn't get into the field only because robots were cool, although they're super cool. But I really got into the field because I wanted to understand humans. I was fascinated by how humans walk, how humans manipulate things, and understanding how we could model these using math and technology and be able to augment humans with the technology that we produce. And through that grad school experience, I learned that robotics can actually serve as a mirror to humanity. So through understanding what technologies we have to build to augment humans, we actually get a better understanding of ourselves. And that is the future I'm hoping for, to be able to build technologies that augment humanity and let us flourish even more. Thank you very much.